Hi students, in this class we will discuss few questions from electromagnetic induction. First question, what is electromagnetic induction? We learned electromagnetic induction in part 7 video in the chapter magnetic effects of electric current. Please watch that video from the playlist before answering these questions. First question, what is electromagnetic induction? Electromagnetic induction is the phenomenon by which an EMF or current is induced in a conductor due to change in the magnetic field near the conductor. You must remember this electromagnetic induction is a phenomenon. In this phenomenon, EMF or current is induced, and this current is induced due to change in the magnetic field near the conductor. Second question, define the term induced current. The current obtained due to relative motion between the coil and the magnet is called induced current. You know, in electromagnetic induction, an EMF or current is induced, and the current which is induced due to the relative motion between the coil and the magnet is called induced current. Third question, write any one method to induce current in a coil. Whenever magnetic field around a coil is changed, a current is induced in the coil. You must remember that this magnetic field must change to induce current in a coil. Question number 4. State two factors on which the strength of the induced current depends. You have to state two factors. The two factors are, first one, rate of change of magnetic flux within the closed coil. Second one, number of turns of the coil. The two factors on which the strength of the induced current depends are the rate of change of magnetic flux and number of turns of the coil. We understood from the third question that whenever there is a magnetic field around the coil is changed, induced current is produced, and the strength of this induced current depends on the rate of this change of magnetic flux, and also it depends on the number of turns of the coil. Question number 5. A magnet kept at the center of two coils A and B is moved to and fro as shown in the diagram. The two galvanometers show deflection. State a reason whether x is greater than y or x is less than y. X and y are magnitudes of deflection. This is the magnet which is kept at the center of these two coils, coil A and coil B. The galvanometer is showing a deflection. In this question, you have to state with the reason whether x is greater than y or x is less than y, where x and y are the magnitudes of deflection. We know galvanometer shows deflection. X is the deflection shown by this, and y is the deflection shown by this galvanometer. What will be the answer? In a previous question, we learned the strength of the induced current depends on the number of turns of the coil. Look at the number of turns of the coil. Which one is having more number of turns, coil A or coil B? Coil B is having large number of turns. Therefore, the induced current produced will be more in this coil B. If induced current is more in coil B, the deflection in coil B will be more. Therefore, the answer is X is less than Y, because induced EMF is directly proportional to the number of turns of the coil. This is the answer. Question number 6. The given figure shows a closed coil connected to a galvanometer G. The galvanometer shows a deflection to the right when north pole of the bar magnet is brought closer to the coil AB. First part of the question is, why does the deflection occur in the galvanometer? In the second part, you have to state the observation when the coil is moved away from the north pole, and B part, both the coil and the magnet are moved to the right with the same speed. What is the question? They have given you a figure, and in the figure there is a closed coil. This coil is connected to a galvanometer, and the galvanometer deflects towards right when the north pole of the bar magnet is brought closer to this coil. And you have to state the reason why this deflection occurs in the galvanometer. What will be the answer for that question? Part 1. As the magnet is moved closer to this coil AB, this magnet is moved closer to this coil AB, the flux linked with this coil increases. When the flux linked with the coil increases, what happens to the induced current? The induced current will increase. The setup induced current in the coil is actually shown by the deflection in the galvanometer. The second part of the question, state the observation when the coil is moved away from the north pole. This is the north pole and this coil is moved away from the north pole. In that case, the direction of the induced current in the coil AB is reversed and the galvanometer shows deflection towards left. When it was brought closer in the previous part of the question, the needle deflected towards right. But when it is away, the needle of the galvanometer deflects towards left. The B part of the question is, both the coil and the magnet are moved to the right with the same speed. The coil as well as this magnet, the coil and the magnet both are moved to the right with the same speed. What happens in that case? Both are moving with the same speed and in the same direction. Will there be any induced current in that case? No. When both the magnet and the coil AB are moved towards right with the same speed, the flux linked with the coil does not change. No induced current is set up. Hence, no deflection is shown by the galvanometer. We learned all this in part 7 video. Please watch that video to understand clearly the concepts. Question number 7. How is the induced current in a secondary coil related to current in a primary coil? Magnitude of induced current in a secondary coil is directly proportional to the rate of change of current in the primary coil. It is always directly proportional to the rate of change of current in the primary coil. Next question. Give two applications of electromagnetic induction. Electric generator, transformer. You can write these two applications as the applications of electromagnetic induction. Question number 9. Two circular coils A and B are placed close to each other. If the current in the coil A is changed, will some current be induced in the coil B? Give reason. What will be your answer? There are two circular coils A and B and they are placed close to each other and current in the coil A is changed. If there is a change in the current, definitely there will be some current in the coil B. The answer is yes. As when the current in coil A is changed, some current is induced in the coil B. Due to change in the current in coil A, the magnetic field lines linked with coil A and with coil B gets changed. This sets up induced current in coil B. Thanks for watching the video. If you like it, please share with your friends. If you have any questions, please contact via email pjscracker@gmail.com.